solving trig equations by switching to tangent. So I want to solve this equation for x, and of course I immediately notice I've got two different trig functions. I don't really have an identity that stands out. The squaring both sides, I could try that, but I think because these coefficients are different, I wouldn't really get any help from that either. Because I do have the 0 here though, there is one thing that I can try. I'm going to move the cosine term to the other side by subtracting it. That leaves me with 2 sine x equals negative 3 cosine x. And then, this is a bit of an unusual step, but I'm going to divide both sides by cosine x. And the reason that I would do that is because on the left, sine x over cosine x, that is an identity. That is just tangent x. On the right side, the cosine x's cancel out. And just like that, I have eliminated two trig functions, and in their place, I just have one. If I just divide both sides by 2 now, I have accomplished step A. Single trig function, single variable, an equals sign, and a number. As long as I can solve this equation, I'll have my solutions to the original equation. Well, step B, find all the solutions within one period. For tangent, that's between 0 and pi. Tangent is positive in the first quadrant, so I must be drawing a second quadrant picture here. Let's see, tangent would be opposite over adjacent. The negative would be with the x coordinate. Well, this is an approximation problem. I will be going to the calculator. This is not a special triangle. Here's the angle I want to find. Obviously, on the calculator, I'll have to use the inverse tangent button. But I have a problem. The inverse tangent button only knows about angles between negative pi over 2 and pi over 2. It's never heard of this angle. So I'm going to have to go to the calculator and do a little bit of interpreting. I will type in tangent inverse of negative 3/2, and then I'll have to think about how that relates to the angle I want in this picture. Okay, we're in radians. Let's type in tangent inverse of negative 3/2. And I get about negative 0.983. Well, how does that link up to the picture that I drew? Remember, tangent inverse knows first and fourth quadrants only. I can't be in the first quadrant because this is a negative, so I must have a very symmetrical picture over here. Here the 3 would be the negative and the 2 would be the positive. Here's the angle that the calculator just gave me. This negative 0.983 radians. Well, do you see from the picture that the angle I want is just exactly 180 degrees past that angle? In other words, if I just take the answer we got from the calculator and add pi to it, 180 degrees, I'll have that angle that I was looking for. Another way I guess I could have thought of it, if this is negative 0.983, clearly this is the same and is also 0.983 in terms of the reference angle. And so all I would have to do is take pi minus the 0.983 and I would have my answer. Well, that's exactly what this says, pi minus the 0.983. So on the calculator, I'll just take that last answer and add pi to it, and that gives me about 2.159. Well, that's the end of step B. We have found the one and only one solution within 0 to pi, the period of the tangent function. Of course, I want all of the solutions, so I do need to do step C, and all I'm going to have to do is take that 2.159 and add in multiples of the period. That would be plus k pi. And we're finished. Thanks for watching.